IBM and a research scholar at JS University. I'm currently doing my PhD at JS University on the computer science for cybersecurity risks and impact on the digitalization of the banking. So today I'm presenting the paper regarding the best citation award. The papers which I published, part of my research, last 3 years, I published around 16 papers, and all of them got a good citations and good reader reviews and comments from the multiple across the globe, multiple authors. And so I nominated myself for this award, and let's see what was my paper, how it got attraction in the international. Today's topic is about real-time anti-fraud tensor. Okay, so real-time anti-fraud tensor link for checks. What exactly it does? What exactly it does? So what we'll do is part of this introduction, we'll go through about what are the topics we are going to cover? Part of it. One is introduction of AFTL4C. What is exactly this? What is this paper? And what was the what is going to be do? What was the why is in this paper? The next we are going to talk about check fraud and impacts. And next we are talking about what is the solution about and what is the key underlying features, these and benefits of it, and key technical implementations and key technical implementations and what are the platform models and conclusion. Let's dive into the exactly the introduction. This is a new AI ML based solution, anti-fraud TensorLink checks for the check fraud detection. As of now, most of the fraud detection applications in the banks have only the batch detection, right? When the customer is submitted the checks, and it will be come to know whether the check is fraudulent or not only after processing the check. So it like at least 24 hours to detect whether the check was qualified or not. But this solution, the paper, we use the generative adversarial networks of AIML, the new CN model, that helps us to identify the real-time check. As soon as you submit a check, within a minute, within a second, you can find out whether the check was counterfeited or modified, or somebody duplicated check is submitting or not. As of now, duplicated check is a real time. Most of the banks have it, but fraud detection, if anybody modified any signature, anything that cannot be identified. And what are the highlights of the importance of fraud detection in the industry? How big risk it is, and what is the need of this, and how much loss it is happening? And the use of within the US itself, $18 billion per year. This is a rise of last year 23%, 23%, and this year 24%. Next, and as the federal bank came up with that number after the COVID, the numbers are rising because of the available technology to the people and number of ways the digitalization of the banks, the way the customers can send the checks to the bank. So that open the door some of the fraudster who can use different techniques and change checks and change the payee name and all the things they can they can get the money from the bank. So money ended up losing $18 billion in the US alone. And if you see the worldwide the numbers, 60% of the check fraud is impacted by the Indian banking, and 40% is impacted by the Chinese banking. And those are the rough numbers, estimation based on the analysis. What is the use of generative adversarial networks? So without using the generative adversarial networks, it's very tough to find out whether the check the check image which we submitted is fraud or not. GAN has its own advantage to find out. That's the reason by taking the advantage of density identity identity model, and the number of underlying features it is able to identify, that is helped us to find out the real-time fraud detection. And this product has a scalability. You can expand as per the bank needs. For example, the bank has to process 1 million checks per day, right? So we can scale up this because it's a cloud native solution. And this solution can be deployed in any of the OpenShift clusters in order to get the better performance on any of the cloud environment or on-prem environment. And this product is also compliance with open banking. Let's deep dive into this next. Check fraud and its impact, right? That's what I explained. So check fraud is inevitable over the years. The banking sector is currently on the rise of to do with something that plays a big role in everybody like money, right? More and checks, money and checks. Any of the big purchases we do, house and anything, the big business or deals, that happens to the check. The check is not new. It's been there for years. It's been there 600 years. In India, that was the first used it. According to the BI, there was 18.7 billions in the US losses annually due to the fraud checks. There is over a million checks a day get forged in the US, right? People will steal the checks from the postal banks and they will forge the checks and go to the bank and they get the money, right? Or in the US, do you know that the check can be claimed? They can go to any of the gas station, they can claim $50, $100, or if the $50 check I got a check for $50, can you pay it? So even government checks, government issued checks for the underpowered people, below the poverty line people, that also will be stealed by somebody else and they will claim. So these are the different scams happening across the checks. Like, I have written a book about this where it talks about different kind of scams that has happened. I published on the Amazon and Kindle. And at the end of the slide, I'll refer that where it is. And compared to the year, the number 2022, the data shows that number of cases has doubled, right? So that's the reason I kept, based on my experience, I've been working in this banking industry more than 15 years and 20 years of my IT experience. And my enthusiasm learning the new technologies and research set of mind and case university professors or guides who helped me to get this thought process into the reality where I came up with this a page into real-time anti-fraud TensorLink. Okay. How it works, let's see. The next slide is about solution work, right? How this solution works. Goals, how it becomes a real-time versus the man or reducing the manual reviews. So the use of OCR, deep learning, and the Google TensorFlow is a solution, right? This can, like, we build a special IoT device which is patented. That can be like it uses OCR, right? But it captures all the details what we require to be feed these details into the TensorFlow model. So this AFTL, we named this product name as the AFTL4C. So you can know learn the details if you're interested. Go to the anti-fraudTensorlink4cheque.com where you can find all the details. The training process of the ATL is using the GAN, generative adversarial network techniques, and historical the database of the fraud line. What we do is a GAN model have two components. One is a generator and another one is a discriminator. We train the discriminator based on using the historical data of the bank, good checks and bad checks, because discriminator knows that how the good check features will be look like, what is the density and how it is the values are going to be. And bad checks also it learns about it. What is a bad check? How usually the amount will be changed? What is the comparison? How the signature will be vary? How the stress stroke of the each visit whenever somebody forged the checks? Those kind of things the discriminator will learn. Generator is the one who takes care of get the information from the input customer and feed that information to that. So while before feeding it, and it knows generator will learn that what exactly discriminator is looking for. Discriminator is like a cop who look for what is going wrong, what is wrong with this check, right? Always try to find the fault in this. Generator is try to who gets a check from the customer, who try to get what is the minimum things, what are the verification will do it. So the generator and discriminator works in a parallel using a machine learning. That becomes a real-time fraud checking. That is the concept behind that we are using it. The next slide is about key features and benefit. If you see the model, how it works, like there is a patent IoT device. On the left hand side on the top you see it. So the image can be captured through any of the OCR device or a patented device which we with the AFTL4 solution. The scalability and configurability in the real time. So this solution can be expandable to any number of checks. As of now, we see that we achieved a process up to 1,800 checks per second with end-to-end response time of 62 milliseconds. The reduction of the counterfeit checks passing through this payment gateway has demonstrated a model testing on a simulated historical datasets. And how this safety improves the fraud detection during the real-time transaction accurately identifies the genuine behavior, reduction of the false positive, right? So sometimes you know what happens, the check is actually not a fraud. But their back office algorithm or somebody identify, oh, this is a check. It has to undergo the scrutiny, like it has to review by eyeball verification. They need to call the customer, they need to verify, cross-verify everything. Then if it is not if it is real check, false positive, then this bank has to spend a lot of money to get all those things in the back office. So that's the reason